Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's very hard puzzle. And it's a continuation, or not continuation, but it's basically, um, yesterday's puzzle was basically a setting which had two different rule sets. And this is the second rule set here. The setting is exactly the same, and basically the rule set changes, which will change the actual puzzle itself, right? So this one is called Chaotic Choice Region Cells by Manta Ray. And the one we did yesterday, you'll see a link in the top left corner here. And it's going to be, it's basically completely different. Well, not completely different puzzle. It's basically the same setting, but the puzzle works completely differently. So basically, it's just a completely different puzzle in the sense of solving it, I guess I should say. Anyways, let's get to the rules of this puzzle. And it's called, let's just get started. We have chaos construction, where we need to divide the grid into 9 regions, each comprised of 9 orthogonally connected cells. And every row, column, and region must contain the digits 1 through 9 once each. So this is an example of an orthogonally connected region, which means you can go from any cell in that in the region to any other cell in the region just by going through edges, all while staying within the region. This would not be a valid region because to get from this cell to any other cell in the region, you would have to go through a corner or you'd have to go outside the region to do that, and that's not allowed. Same with this. This is not a valid region because even though you can get to each other by going through an edge while staying within the region, they can't get to the other cells in the region by going through edges all while staying within the region. So that's example of how chaos construction works. We have arrows where in this version, the digit in an arrow containing cell defines how many region cells, that is cells belonging to the same region as the arrow cell, can be seen from the cell in the indicated direction, not including the arrow cell itself. Let's use, let's see if we can come with a better example here. Let's say we have something like this. That's 8, that's 7, 8, 9. If a cell contains multiple arrows, the cell's digit is the total number of region cells seen in all indicated directions. I believe the in is a typo because otherwise it doesn't make a complete sentence. So basically, this counts how many cells in these directions that are seen, right? So this would be basically 1, 2, 3, because this cell is not seen because region borders block vision. So this would have to be 3 because it sees 3 other cells in that region. This would be 0 because it sees 0 cells that way. This would be 1 because it sees 1 cell there, and this would be 2 because that sees 2 cells in the same region that way. This would also be 2 because it sees 0 cells this way, it sees 0 cells that way because its region borders blocks vision, and it sees 2 cells that way. So obviously this is not the correct region because we have a 0 in it and we have 2 2s in that region. But those are examples of how arrows work. And just a clarification, a cell with multiple arrows may see no region cells in one or multiple indicated directions, as long as one or more region cells can be seen in at least one of the indicated directions. So, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So this cell and this cell. So these two cells are interesting. This, actually, all of these cells are interesting. This cell points to cells that are in the region here. So that means this must be in the same region. Same with this. So this is always going to be 1 greater than this. So this must see at least one cell. So it sees one cell that way. Same with this. This sees one cell that way. So this is at least 1. So we can see 1, 2, 3, 4, 5, 6, 7 at most. So this will see 7. And this will see 2 through 8. This will see 7 at most. And this will see 2 through 8. This must be part of the same region here, and this must be part of that region here. This could all be part of the same region, period. And in fact, it has to be. If it's not, then these will block here. This sees 1 cell, and so it would have to be 1. This sees 2 cells, and would have to be 2, but this would be the same thing. This sees 1 cell, and this sees 2 cells. So this has to be all the same region. That means this sees 4 cells here, and this must be 5 cells. So this can't be 4 or 5. Actually, so I guess we'll make this not dark. We'll make this medium, because it's going across the entire... So this is 4 and 5. This must see more than 5 cells, so it has to see 6 cells this way. So then this is 6. This sees 7 cells that direction. This sees 7 cells here, so it must see an 8th cell. Sorry, it sees 6 cells here. It must see 2 more cells here to see 8. So then this is 8. That means this sees only 2 cells this way. Wait, 1, 2. No, that's not possible. Hold up. Wait. No, okay. That's right. This is right. So we have 8 cells here. This sees one more, so this is 8. Right, so that is correct. So this cannot be 4 through 8. It's therefore 2 through 3. This must then be 1 or 2. So we have boundary. Okay, let's draw the boundary around the edge of the grid. And we have a boundary here. This is done as a region for the medium region. I guess we could have made it dark, but... This has to be blue, and that must be the same region as that. This sees no digits in the same region as there, so let's make this actually dark again. And this will make medium. So this has to see at least 1 that way. This sees 1, 2, 3 at most. So that's 3 at most. It must see 1 in this direction, though. This sees at most 1, 2, 3, 4, 5, 6, 7. This sees 1 that way also, so that's fine. So this has to be 2 or 3 corresponding to this. That means the remaining digits in row 1 have to be 1, 2, 3, and 9. 1, 2, 3, and 9. So again, this sees 6 cells that way, this sees 7 cells that way, this sees 4 cells, 5 cells, and this sees 8 cells. So 9 can never be essentially in an arrow spot, because if it were, it would not be part of that region, right? So 9 in row 3 has to be either here or here. That means one of these must see 8. I guess this, so this is 1, 2, 3. Or it's 1, 2, 3, 4, right? Which would see 3 cells. Hmm. None of these can be 9. This can't be 9, so 9 cannot be here. Where is 9 in column 6? It must be one of these two. This is 1, 2, 3, 4, 5, 6, or 8. This sees only 1 that way. It would see 2, 3. It cannot be. Well, this could be 9. So this could be the same region as this. So it could be 1, 2, 3, 4, maybe. Okay. So say this was 9. Okay, so basically, if it does see 4 this way, these have to be the same region because there's no other place for these cells to be part of another region. But wait, this can't be 5. 1, 2, 3, 4, right? So then this would also see 4 if that's the case, right? It would see 1, 2, 3, 4, and that's not allowed. So this has to be a different region then. So this sees 1, 2, or 3 here. This sees 1, 2, 3, 4, or 5. So it could be 1, 2, 3, 5 there. Hmm. If these were all the same region, could be. Could see cells that way. This sees 1, 2, at most 8. This is at most 8. But if it were to be all 8, the problem is this would see 1. Well, that's fine, actually. This could be 1. This cannot be then the same as this. So this can see at most. This sees at most 1 that way, and then 1, 2 that way. So this is 3. So we have a 1, 2, 3 triplet in column 1. Because this sees that. Okay, so say this was 1, that's 2, this is 3. So 2 has to be one of these two, which means this cannot be 2. So this sees either 1. So if this is 3, 2, 1, again, if this is 1, this is 2. If this is 2, that's 3. So if this only sees 1, how does that work? I guess you could do something like that and then go on from there, or something funky like this, right? If you see 3 that way, then this would be 2 and 1. Oh, this can't be 3. If it sees 3, this would be 2 and 1. So therefore, this would see these two only, and therefore couldn't be there. This would see 0, and this would see 2 that way. So this can't be 3. It's 1, which makes this 2 and 3. Therefore, this sees 1 more. 3 sees this 3 that way, so this is 3. So that's the boundary there. This is a boundary here because this only sees 1 in both of these directions. We'll make this green. This sees 1, 2, 3, and it must see another one here. So that's at least 4. So 4 through 9 that way. This cell cannot be part of light. It could be part of medium. So, and this 1 eliminates 1 here, so this must see that cell also. And this cannot be part of light, it has to be part of medium because there's no other region it could be part of. So this is medium, it sees 1, 2, 3 at least. So this 1 eliminates 1 here. This sees at least 3 because it has, well, it can see 2. 2 through 1, 2, 3, 4, 5, 6, 7, 8. Can't be 8 though, because we have 1 digit here. These are light or medium. We're not sure which. 2, 3, 4, 5, 6, 7. It can't be 8 because if it's 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 would be a region which is not allowed. It could see 7. 1, 2, 3, 4, 5, 6, 7. Actually, it can't see 7. If we try to have it see all of, well, we try to have it see that. So that'd be 1. So that would be 1, 2, 3, 4, 5, 6, 7. That would be 8 and 9, but then this would have to be medium to form a region. So this can't be 7. So it could see 6. This sees 0 that way. So this is a border here. This sees, cannot be 1, 2, or 3. So this must be 4 through 9 here. And it can't see 9 because it can't see any of these. It can see up to 6. So this sees these 3 and whatever these see also. Right? Because they ignore them. Okay, this can't see 9 ever again. So this sees 4 this way, at least. Which means this must see 7 then. So it's 7 at least. So this sees at least 4. So we have light all the way there. This cannot see 6 because it would just... So this is 4, 5, and this is 7 or 8. So if this is 5, that's 8. If this is 4, this is 7. Medium has to go... Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8. Therefore, this cannot be light. It has to be medium. These must both be medium, and medium must go out this way, at least, because we only have access to at most 8. This sees then 1, 2, 3, 1, 2, 3, 4. It cannot be these, so it sees 1, 2, 3. So it has to, well, it could see that way, right? So this is 4 or 5. This sees 3 exactly. This sees 2 at least, and it cannot see more because it can't be 3 or 4. So, and you can only have 1 more here, so this must see 2. So this is 2, which means this is a border this way. This is 4 or 5, so you could, so this, this sees 2, this sees 1, 2, 3, 4, or 5 going that way. So we have a 4-5 pair in this row, which means the remaining digits are 6 through 9. And this can't be 9, 6 through 9, no 6 here. 6, 8, and no 9 there, so 6 or 8. So we have boundary this way. This could be medium here. Light has 1 more, so light can be any of these. And medium could be here. This sees 1. So that's 1. That means the remaining digits in the medium gray are 6 through 9. 2 eliminates 2 here, so this is 3, which eliminates 3 in the rest of the dark region. So these are not 3. It's 1, 2, and 9. So, yeah, one of these is 4, the other one is 5. If this were to include that, the problem is it would see 0 cells going that way. So this cannot be medium, it cannot be light, because that would see 0 cells that way. So this must not be light here. This has to then be, because this has to be a boundary. So then this sees 1, 2, 3, 4, and this sees 1, 2, 3, 4, 5. So we have 4 here, 5 here, which makes this 4. This sees 4 that way, so this sees 7 total. Right? 1, 2, 3, 4, 5, 6, 7. This is 6 through 9 here. If So one of these is light. It cannot be here, because if that's light, that only sees 1 cell. And we already have a 1 in the region. So these have to be 5, 6, 8, or 9. No 5 here, no 9 here either, because of 5 and 9 in the column. Green could go here. I don't know. This has to be part of the region there, so we'll make that pink. Remaining digits of row 5 are 1, 2, 3, 5, 6, 8, 9. No 3 and 8 allowed here because of 3 and 8 in the column. 9 cannot be on an arrow again. No 6 here. These have to be 2 different regions, right? If they tried to make it part of the same region, you'd have to see at least 6 here and at least 6 here, and that's not allowed. So these have to be separate regions. This could be part of pink. So we're going to make this yellow and orange then. So one of these, well, we don't know. This sees at least 6. So it could be 1, 2, 3, 4, 5, 6 at most. This sees at least 6. 1, 2, 3. Oh, wait, doesn't include itself. So this is at least orange. This is at least 5. This could be part of yellow. Because it could see 1 here, and then you could see, well, hold up. This sees 6, so 1, 2, 3, 4, 5, 6, 7, 8, 9, right. So that could be part of the same region. Okay. If this is 3, that means all of... Okay, so 7 eliminates 7 here. Remaining digits in column 1 are 4, 5, 6, 8, 9. No 9 here. Technically, this could see 7. Right? This sees 1, 3, 5, 6, 7, 8, maybe. But this can, if this were part of this cell here, or this region here, the problem is it would not be part of this one. So realistically, this is at most 1, 2, 3, 4, 5, 6. Um. mhm. Okay. This is one guaranteed. 2, 5, 6, 7. Hmm. If this were to C8, that would be 1, 2, 3, 4, 5, 6, 7, 8. But then this would see 0 cells. So this cannot be 8. This is 6. Which eliminates 6 here, 6 here. So this is 7, 8, and 9. So this must extend one more here. So this sees 6. Cannot be 6. It can't... Could be 1, 2, 1, 2, 3, 4, 5, 6. So let's say it went that. It could do that. Okay. This has okay, so this sees 7 at least. So 1, 2, 3, 4, 5, 6, 7, 8. So this has to be a different region. So this is pink. So this sees nothing that way. Oh, this could see this way. I totally forgot about that. Okay, or didn't forget. I just didn't see the arrow. So this could actually... It can't be 8, though. Never mind. This just can't go that way. That was the thing that I was looking at there. This sees... Can't be 6. Sees only 5 at most that way. There has to be another region here. Because this is too few. So you could have 9 here. So 1, 2, so you could have 9 all the way here. So 1, 2, 3, 4, 7 this way. So this cannot be, this could be part of this region, technically. Actually, can it? So say it was part of this region and extends out this way. This has to have C7 cells. 1, 2, 3, 4, 5, 6, 7. I guess it could be that. But, okay, well, the problem with that... So say this was going this way and extends to here. So 1, 2, 3... Sees 1, 2, 3, 4, 5, 6. We have 7 and 8 as part of the region. This is 9. The problem with this is then... This would have to see 7 cells. 1, 2, 3, 4, 5, 6, 7. But the problem is this can't form a region then. So what happens if we say go here? Or let's say we go here. Maybe that's the cleanest. So if this were the same region, this sees 7. This has to be a region by itself, but it's 1, 2, 3, 4, 5, 6, 7, 8 at most. So therefore, these cannot be the same region. Therefore, blue has to include some of these. So orange can fill out at most 9 here. Well, okay, let's see. 1, 2, 3. So it sees only 6. 4, 5, 6. So we go... Or say we go 6 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That doesn't really work. Let's go yellow, yellow here. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Right. If we tried to close yellow out that way, I don't think it works. So say what happens if we make that yellow? This is not large enough to form 3 regions. It's 24 cells, 3 by 8. And that's not enough. So blue has to extend out, which means yellow has to see 1, 2, 3, 4, 5, 6, 7. So this is definitely 7 here. And this is 7. So this can't be 7. This is 8 or 9. This can't be 7. It's 8 or 9. So that eliminates 7 from the rest of the column. This sees 6. So that's 6 there. That eliminates 6 in the rest of the row. This must see 6, so this is orange, and this is orange. So we have 1, 2, 3, 4, 5, 6, 7 oranges. Orange has 2 more. So this is border. Yellow has 1 more. Orange has 2 more, and yellow has 1 more, which means all of these are blue. So we have boundary here. This can't be 6. We don't know, actually, this is a border. Blue could extend this way, and you could have both oranges here and yellow going this way. So this cannot see 5. It sees 1 or 2. Interesting. Okay. So this 8, 9 has to be one of these 2 cells here. We don't know which. This can see at most, so we have 1, 2, 3, 4, 5, 6, 7. We can see at most 8 and 9 left, so this would be at most 5. This... So yellow cannot be here, because if this is yellow, it would just see 0, right? Because we already have 8 cells already. So this cannot be yellow. This cannot see then more than 5, so this is 1 or 2, which eliminates 1 and 2 in the rest of... Wait, but we have a problem. Oh, this is 1, 2 as a pair. This... So this sees 1, and it cannot be same as pink. So it can't be yellow. So then this has to see... I don't know. It could be blue? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. It probably has to be... Well, it could be red. We're going to mark it as red for now. This C cannot be all 4 there. So if this were 1 seen this way, it would have to go... It can't go here. It can't see all 4 there. So this must then see 2 there. So this is 2. So we have 2 here. This is 1. It's likely blue. Yellow cannot go there. So therefore, this is orange and yellow as combinations. We don't know which. 2 eliminates 2 here. This can only see 5. So it sees 1, 2, 3, 4, 5. So these are all pink, not light. Therefore, light goes there. So that's done as a boundary. This has to be a boundary. Green has to go down. Not red, green. This is 5, 6, 8, or 9. Cannot be 5 because of 5 in the column. So 5 in light region has to be one of those 2, so this cannot be 5. Okay, this sees 5. So, and this sees 1 or 3. It could be either one still. Remaining digits in column 6 are 6, 7, 9. This can't be 9 because of 9 in the row. This could be blue. Okay, so this is boundary there. We have to have a 7 in, well, orange has to have a 7. In, yeah, orange has to have a 7 available, so one of these two is 7 and is orange. Which means 7 cannot be here, 7 can't be here. In blue, 7 could be here or here, depending on if this is blue. This sees 1, no matter what. That means this can't be 1. This sees at the most 1, 2, 3, 4, 5, so this can't be 6, 7, or 8. So I think most of the arrows are done. This can't be 1 or 2. It sees 3 at least. 6 eliminates 6 here. And this can't be 5 or 6 either. So 6 in the light region must be one of these 3. Oh, we already removed 6s anyways. Oh, interesting. 6 has... Okay, remaining digits of row 2 are 4, 5, 6, 7, 8, 9. But 6 obviously cannot be any of these. 7 can't be here because one of these is 7. So this can't be 7 here, which means this is 7 here and is orange. So this is boundary there. We have 4 and 5 and 1 out of 8 or 9. Okay, so whatever's yellow here has to be in these two cells here. Well, we're guaranteed a 2 here, so this cannot be 2. You could have 1 here, or you could have 4, 5. So this is 1, 9. This can be 1, 3, 4, 5, 8, or 9. No 9 because of 9 in the row. Remaining digits of row 5 are 1, 2, 3, 4, 8, 9. And this can't be 2, this can't be 1, 3. And this can't be 9. So it's 2, 4. This can't be 2 because of 2 in the region. So therefore that can't be 2. We have a 4, 8, 9 triplet in row 5, which limits 4, 8, 9 in the rest of the row. This can't be 4, 8, 9. It's 1, 3 as a pair, which means this has to be a 2. So this is 2 here. Hmm. 6. This is much easier than the previous one, I must say. Um. Hmm. Though the completion of this seems a little bit more difficult. Let's continue. What else do we have available in column 7? We have 1, 2, 3, 4, 5, 8, 9. Obviously, this can't be 1 because of 1 in the row. In column 8, we have 1, 2, 3, 4, 5, 8, 9. This can't be 1 either. No 9 here. Hmm. Hmm. Um, hmm. Remaining digits of column 4. 2, 4, 6, 7, 8. Pretty broad. Okay, let's say this was all part of the same region. So if we had that, so say this was 5, essentially. Does that work? I don't think so, right? We have 7 here, 8, 9. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as a region. So this can't be 5. It's 2, 3, or 4. Hmm. This can't see 8. Can't see 6. Can it see 5 even? If we had 5 here, so this would then be the same region. 1, 2, it could be part of green. But then this is too large of a region. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this cannot see 5 because if it's not if it's not part of green, that would block green in, and green and pink can't be the same region because it's too many digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this cannot be 5, it's 4. Which means this is 4. Oh yeah, this had to be part of the same region. So we have 4 cells that are part of the same region, which means it's not red. But it's probably, if it's not green, that means green is stuck here and this is too big. So it has to be part of green. So this, we have 1, 2, 3, 4, 5, 6. So this cannot see 3 cells here, so this must see 1 cell. So that's 1, that's 3. So therefore, this is not part of pink. Which means we have 1, 2, 3, 4, 5, 6, 7, 8, 9 here. So this is all pink, which means this must be green. So this is boundary here. This is likely part of blue. 3 eliminates 3 here. We have... Oh, wait, this can't be 4. Because if this is 4, this is only 1, 2, 3, 4, 5, 6, 7, 8 cells. And we need a green in one of these cells here. And obviously, if this is green, it sees 0 cells. If we have green in any of these, this cannot be 4, so this must be 2. So that eliminates 2 in the rest of the row. 2 here. We have, where's 2 remaining in row 1? It has to be there. This cannot ever see 2 more here. But it could... Okay, so this 2 eliminates 2 here, so this is 1. So this cannot see these digits here. So this is boundary here. This is obviously boundary here. We're gonna make this non-red, but so red is here. That means it sees at most it could be these two, can't be these two. If it's just these two, the problem is blue can never reach here. Green can't be here because this only sees 1. So this has to be red. So we have either red here or red here. Blue cannot reach either of these, so this must be red or green, and this must be red or green, because it sees 2 cells that way. Blue, 1, 2, 3, 4, 5, 6, 7, can never reach here. So then this must be, one of these is guaranteed to be green, so this can't be green, that's red. Since this is red, if this were red, it would see more than 3, so then this has to be green and not red, and this can't be green. That's red. So then red has to connect this way. which means this is blue. Okay. So then we're done with the boundaries. Yeah, this is much easier than the previous puzzle. This sees 2. This sees 1. We cannot... Okay, so remaining digits in the pink region. So you cannot have 2. It's 4, 6, 7, 8, 9. This 8, 9 pair eliminates 8 and 9 here. So this must be 4. This can't be 4 because of 4 in the column. And where's 2 in column 4? It has to be here. 4 eliminates 4 in the rest of the pink region. We have a 6, 7, 8, 9 quadruplet in row 6 now, which eliminates 5, 6, 7, 8, 9 in the rest of the row. No 6, 8, or 9 here. It's 5. That leaves this no 5, 8, 9. We have 1, 2, 3, 4 remaining. This can't be 1, 2, or 4 because of 1, 2, 4 in the green region. So this is 3, which eliminates 3 here. No 2 here because of 2 in the column. This can't be 1, 2, or 4. No 1, 2, 4 here. No 2 in either of these cells. Where's 2 in column 7? It has to be here. So this is 2, which eliminates 2 here. Where's 2 then in column 8? It has to be here. So that's 2. We have 1, 4 as a pair. 1 in the blue region means this can't be 1. It's 4, which makes that 1. That eliminates 4 from being here, which means this can't be 4. This can't be... Actually, this only sees 3. So this has to be 3. We're missing a 3 in the orange region, so it can only be here, and therefore this is orange, which means this is done as a border. And this is yellow. This is not orange. We have 5, 8, 9 missing in yellow, so this has to be not 1, so this is 9, which makes this 1, because we have to guaranteed 1 here. That means this can't be 9. No 9 here. This can't be 3. So this is 5 or 8 here. We're guaranteed a 9 here, which means this can't be 9. Yeah. So 1 here eliminates 1 here. That's 8 or 9. That matches that. Remaining digits of column 9 are 4, 5, 8, 9. No 4 here because of 4 in the row. This can't be 3 or 4 because of 3 and 4 in... Wait, we have a 5, 8 triplet. That's not going to work. We're missing a... How are we missing a 1? I have too many 1s. I have too many 2s. Okay, I messed that up. I'm not sure where I messed it up. This is 3. So this can't be 3 or 4. No 1 here. Oh. Yeah, I kind of messed that up. I don't know why I said this can't be 1. Oh, because this has to be 3. Yeah, problem. Huh. That's a big problem. Huh. How did I mess this up? Okay. This can't be 9, so therefore this is 9 here. This is 8, 6. No 8 here, no 8 here. No 6 here. 6 here. This is 6, 7, 8. Means no 6 here. Yeah, That's really problematic. Oh, wait. How do I know? Well, no, that has to be 4 because of the blue. Dang it. There's no place for the 1, though. Hmm. Huh. I messed up somewhere. I'm not sure. Where? No 9 here, no 6, 8. This is 5, 7 as a pair, which makes that 9, that 5. No 7 or 9 here. It's 6, 8 as a pair. Ugh. No 3 here. No 4 here. So 5 can't be here, therefore this is 3. Eight, 1, 9. Yeah, it's a little problematic. This is 1. 1 can't be here, so 1 is here. So we have 3 and 4 here. And then we have a problem. So, yeah, we kind of messed up somewhere here. Shoot. Oops. Time. Dang it. I'm not sure where I messed up. Okay. I think this was all kosher here. Obviously, these must be part of the same set. This must be part of the same set. These are part of the same set. And again, if these are different sets, this sees only 1, that sees only 2, this sees only 1, that sees only 2, and we have a duplicate, so it cannot be that way. Therefore, this sees 4 this way. Did I make it dark? Yeah, I think it's so. So this sees 4 cells this way. This is 5. This must see more than that, but it sees 4 there because... So this must be 6 and 7. This must see 8 because all of these are dark. Right? This sees 1, 2, 3, 4, 5, 6. This sees 7. This sees 7 here, and it must see 1 more to make a valid number. Again, we tried. This has to see cells here. And you cannot connect these because then these would be all the same region. This sees 2 or 3, 1 or 2. Because this cannot be 4 through 8. This sees only 1, 2, 3, 4 at most, but we tried to have 4. If we have 4, then these are all part of the same region. This would then see 4, and then we'd have a contradiction. So this cannot be 4. These are separate regions. Therefore, this sees at most 1 going that way, because this sees at most 3 there. So 1, 2, 3. So this is also 1, 2, 3. Cannot be... One of these is 2, so this sees 1, so therefore this can't be 2. If this tries to see 3 here, this would be 2 and 1. So therefore it would see 0 here and 2 here at most, so that's not possible. So this is 1, that's 2, that's 3. So this sees 1 that way. Therefore, this is boundary here. This only sees 1. This is boundary here. So this must see at least 4, so therefore it must go that way. This sees 0 here because this is this is not part of the same region because this can only see 1. So this has to see at least 4. So this is at least 4, and it could be 5. So this is 4, 5, this is 7 or 8. This has to be medium because it can't be light. So therefore this sees all of these. This sees 1, 2, 3. So this is 3. This sees 1. So this is 1. Boundary here. Medium has to get out. So it has to go. This is at least 8 at most. So it has to go dark here. You can only have 1 cell here. So this is medium. This is medium or light. This is boundary here. This sees, we have 8 cells guaranteed. So it sees 4 at most, at least, and then 5 at most. So this is 4, 5. This sees 4 here, and it could be 1 here or 1 here. So this is 4, 5 also. But if it includes this, then this would see 0 cells. So this is boundary. We have 4, 5. This sees 2. So that's 2. That leaves 6, 7, 8, 9 remaining. 6, 7, 8, 9. No 9 here. No 7 here. So this cannot be part of the same region as this because this sees 6. So we'd have to see 1, 2, 3, 4, 5, 6. So that'd be 7. And this would then see... Hold up. Maybe this could be part of the same region. Maybe that's the issue. Let's try that. If it sees that, so this sees 2. That doesn't work. This would have to all be orange. And then we'd have... This could only see 5. Yeah, just can't... They have to be different regions. So we have orange here, yellow here. This must be seeing at least 1 region. So it has to go that way. This must be part of the same region. This cannot go down because if it goes down, it would be part of... It would see 0 cells. So this is boundary, which means this is not light. Again, same here. If this goes all light all the way here, then this would see 0 cells. So this is boundary here. This sees 4, this sees 5, which makes that see 4, which it does. This sees 7 then. 1, 2, 3, 4, 5, 6, 7. So we have boundary here. We have 1, 2, and 9 here. 1, 2, 9 here. 6 through 9 here. 6 through 9 here. This is 3, because we don't have a 3 in the dark region. This sees at least 6, so we have 1, 2 at most. So it must be 3, 4, 5, 6. So these are guaranteed orange. Same here, 1, 2 at most, 3, 4, 5, 6. So these are our guaranteed yellow. If we try to have this as 8, that would be 1, 2, 3, 4, 5, 6, 7, 8. But then this would be a 9-cell region, and that would add a 10th there because this has to be at least 1. So this cannot be 8, it's 6. There's no 6 here, no 6 here, no 6 here. So we add a yellow to 7. again, this if this were tried to be 8, that would be 1, 2, 3, 4, 5, 6, 7, 8 cells seen. And then the problem is this doesn't form two fully regions, and it doesn't form just one region, right? So this cannot be 8, it's 7, which means this can't be 7, no 7 here. This is 4, 5, 8, and 9 as possibilities. If we cut this off, again, we have the same problem, right? 1, 2, 3, 4, 5, 6. So this is 7 that it sees, which means it cannot be part of this because this must be part of the same region there. So this sees 1, 2. It cannot see 5 because that's too many cells. So this is 1 or 2. This is blocked as a region here because, again, if we tried to include it, this has 8 cells already, plus 2 is 10. Blue has to continue out here because if yellow blocks it, there's just not enough to make 2 full regions. And then you can't have 1 full region from what's left. So blue has to go out this way. This is 1, 2, 3, 4, 5, 6, 7. So those are yellow. Then this sees 6. So it must be 1, 2, 3, 4, 5, 6. We have 7 cells. So we have 2 more oranges and 8 cells. So 1 more yellow. So this is orange or yellow. These are orange or yellow. And these must be blue. Blue has to continue out this way. Oops, no boundary necessarily there. So blue has to go out that way. So it's 3, 4, 5. This sees 1, 2, 3, 4, 5, 6. This cannot be part of yellow because we have 8 yellows already. Yeah, we actually don't have that one yet. This could technically be blue. This can't be yellow, though. Because if it were, they would see zero. No, it would see 1 cell. So this could be yellow. Oh, that's where I messed up. That's where I messed up. Though I don't know how you find that. That's pretty convoluted to find. So this could be yellow because it sees 1 there that way. Huh. Interesting. This sees, it's either yellow, which only sees 1, or it's not yellow, which could see up to 2, because this cannot be the full length that way. So this is 1 or 2 also, which means this can't be 1 or 2. It has to be 5, but this only sees 2 at most this way, which means this is 2 at most this way. It cannot see all 4 that way. So if it tried to see all 4 that way, then light doesn't have a full region because it only has 8 cells. So this has to be then 5, and it sees 3 this way, and then 4, and then 5 here. So then this sees 2, this is 1, but it could be part of yellow. And in fact, we've shown that it has to be part of yellow because of the contradiction that I ran into. This is light. Green goes here. Okay, this sees 1 or 3. Could be 1. Cannot be. So we have 6 here. It could add 7, 8, 9. So this could be 1, 2, but it can't be 2 or 5 or 4, so this is 1 or 3. Okay. So this could be yellow here. Oh. Okay, remaining digits in the light region, 5, 6, 8, 9. 5 cannot be here, 6 cannot be here, so we're guaranteed 5 and 6 here. No 5 here. which means we have 1, 3, and 8 and 9 also. Remaining digits of column 1, 4, 5, 6, 8, 9. This cannot be 9 here, no 5 or 6 here. This cannot be part of the yellow, blue, or orange region, so it's at most 5. Huh. But it could actually be all 5 there. That's possible. Is it, though? If... Okay, we have... Yeah, it could be. Okay. This sees cannot be part of yellow, cannot be part of blue, cannot be part of orange. So this is 5 at most also. Cannot be 1. So it's 2, 3, 4, 5. This is 1, 2, or 3. So this has to be part of this cell here. So this sees at least 4. And is probably green. Actually, it has to be green. If it's part of a different region, the problem with that... So if it's part of a different region, green can only go here. It cannot be part of pink because that's too many cells, but then it only has 6 cells if it's blocked here. So this must be green. So this is green. That means you cannot go green, green here because then that's 9 cells, but then this wouldn't have a region. So this cannot be 3, but you could do 2 down here. Okay. Remaining digits of column 6 are 6, 7, 9. Remaining digits of column 4 are 2, 4, 6, 7, 8. 6 eliminates 6 here. This can't be 2 because of 2 in the box. Or the region. Can this see 5? No, because you'd have red here, red here. It would have to be red here, and that would be too large. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it cannot be 5. It's 2, 3, or 4. Yellow could be either of these. If this is yellow, then this fails. So that can't be yellow. But this could be yellow. This could be green or pink. It cannot be yellow, guaranteed. This could be blue. And this could be blue, I guess. So it could be blue. You could have red also there. So that's a lot of possibilities. These are pink and green. Interesting. So this cannot be 3 going that way. Because you can't see 1, 2, 3. So this is 1. Remaining digits of row 5 is 2, 3, 4, 7, 8, 9. And this can't be 2 because of 2 in the region. No 7 here because of 7 in the region. If, again, we have that... So we know that this can't be blue, because if we try to make that blue, that's 1. Which would force this to be 3. I mean, that's okay. So this has to be 1, 2... So we have 7 here. And 6 here. That's 13. We have green, red, green, green, pink, green, pink, green, pink. So that means that's 4 there. So that's 17 for pink and green. We can only have one more pink and one more green. Or one more green. That's it. So if this were green, the problem with that is it would not be able to see 2, 3, or 4. It would see 0. So this is boundary, and this has to be red. Where can blue go? We have 7 guaranteed here, so blue can go 1, 2, 1, 2, or 1, 2. So the rest have to be can be red. Green could technically go 2 here. Cannot go 2 here because this is could go green here. Could go green in any of these spots. So these are the red guaranteed. Again, we tried if this is 1. That means this is 3. Does that tell us anything? I'm not really sure. This is 1, so this cannot be pink. Okay, so then this has to be green. So we have green here. We have... This could be pink. That means we have 8 greens. 1, 2, 3, 4, 5, 6, 7, 8. We cannot go green there, so that's red. We only have one more green here. We have boundary here. Hmm. Yeah, so I previously had this had to be 4, so that's no longer valid. Hmm. We have to have a 7 in orange. And it cannot... Oh. It cannot be here, here, or here. So that's 7 in orange. But that means blue can't go here, which means yellow does have to be one of these, which means this can't be yellow. Oh, okay, we still have the same problem then. Dang it. Because orange can only take 2 of these. Can't take all of them. So this can't be 7. No 7 here. We have a 3, 4, 8, 9 triplet, which forces that to be 3. That forces that to be 2. So this is 3. So then this has to be 2 digits here. So this cannot be pink. Which means this is all pink. Ugh, not liking it. Hmm. Oh, well, okay. No, so this was still okay, so this can't be green because this has to be the same. But we tried that other way, right? We tried this as blue. Then this is 3, which means orange needs a 3. It has to be there, but then there's no 1 available in column 8 at all. So this cannot be blue. So this is red, which means this must be red here. Blue has to be all of these, so these cannot be red. This has to connect to red. Oh, and then it goes this way. So then this sees 1, 2, 3. Can't be 3. So it must be 4. How did I not get that before? I don't know. So then this Maybe, yeah, I don't know. Maybe it's not valid to be 4? I don't know. This has to be 4. This is 1. This can't be 4 anymore. No 4 here. 8, 9 as a pair, which means this can't be 8. It's 4. No 2 or 4 here because it's pink. We have 6, 7, 8, 9. This can't be 4. No 4 here. This is not red. How did we... I don't even know. So this has to be 5. Which means orange has to be missing a 5, so therefore orange has to be here. Which means this can't be orange, it's yellow. So we have to have a 5 here, which means this can't be 5, no 5 there. I don't know how I got rid of the 4 there then. That's weird. Yeah, no 4 here. One eliminates 1 in the rest of the column. One, 3, 8, or 9 is one of these. So this is 1, 3, 8, or 9. No 9 here, no 2 here. One of these is 2 guaranteed. This is 6, 7, 8, 9, so this can't be 6, 8, or 9, so it's 5. No 5 here. This becomes 1, 2, 3, 4. Can't be 1 or 2 or 4, so that's 3. This is 1, 2, 4 then. No 2 here. That's 1 or 2 or 4, that's fine. We have 5, 6, 8, 7, 8, and 9 remaining in column 5. No 9 here. Because of 9 in the row. This has to be 2, 5, 6, 7, 8, 9. No 5. This can't be 5. Because of 5 in the region. 5 eliminates 5 here. We are guaranteed 9 has to be one of these 2 digits, which eliminates 9 from the rest of the region. Remaining digits in... Okay, so 5 eliminates 5 here. We have a 6, 7, 8 triplet now in row 9. Which eliminates 6, 7, 8 in the rest of the row, so no 8 here. We have 1 through 4 here. 1 through 4 here. This cannot be 1 or 4. This becomes a 2, 3 pair. 3 eliminates 3 here. So that's 2 and 3. This can't be 3, it's 1. This can't be 1, 2, 3, it's 4, which eliminates 4 in the rest of the column. 1 eliminates 1 in the rest of the region, so that's 2. This can't be 1 or 2, it's 4, which makes that 1. No 1 here. No 4 here. So 1 is here, which means this can't be 1, that's 9. Which makes this 2, which makes that 1. 9 eliminates 9 here, so that's 8 and 9. This 8, 9 pair eliminates 8 and 9 in the rest of the row. 1 eliminates 1 here, so that's 3 and 1. This can't be 3 anymore, it's 8 or 9. This can't be 8. No 8 here, so this is 6, 7, 9 as a triplet, which eliminates 6, 7, 9 here. So that's 4. The 6, 7, 9 eliminates 9 here, so that's 8. No 8 here, no 8 here, no 8 here, no 2 here. So we have a 6, 7, 9 triplet in column 3, which eliminates 6, 7, and 9 in the rest of the column. So no 6 or 9 here, so it's 5. No 5 here. 2 and 3 eliminate 2 in the rest of the red region. So this has to be 5 through 9, but no 5s available because 5 in the column. Where's the 5 in the red? It has to be here. So this is 5, whereas 2 in the green, it must be here. Which leaves this as 3, 6, 7, 8, 9. And obviously this can't be 3, 6, 7, this... Wait, we have a problem. We have 5 also, okay. And 5 cannot be either of these two, which is why I was like thinking this is a contradiction. So this is 5, that's 2. This is, one of these is 3. So we have 3, 6, 7, 8, 9 here. No 6 or 9, no 6 or 7, no 7 here. Um, remaining digits in row 8 are 3, 6, 7, 8, 9. No, one of these is 7, so this can't be 7 here. 9 is not allowed in... This can't be 6. This is 3, 8 as a pair, which eliminates 3, 8 in the blue region. So this is done here. That means this can't be 8. 6, 7 as a pair eliminates 6, 7 in the rest of the row, so this can't be 6. It's 8, which makes this 9, which makes that 6. 9 eliminates 9 here, so it's 8, which means neither of these can be 8. None of these can be 8 in the red region. Where is the 8 in pink region? It must be here, which means this can't be... Well, this couldn't be 8 anyways. This 9 eliminates 9 here, so that's 6 and 9. 6 eliminates 6 here, so it's 7. 9 eliminates 9 here, so it's 8. No, 8, 6, 7. So this is 3, 9 as a pair. 6 and 7 eliminates 6 and 7 here, so it's 9, which means that's 6. 9 eliminates 9 here, so it's 3 and 9. 3 eliminates 3 here, so it's 8 and 3. 6 eliminates 6 here, so it's 7. This can't be 6 or 7, it's 8. 6 eliminates 6 here, so it's 7 and 6. No 6 or 7 here, so it's 9. No 6 or 9 here, so it's 7. No 7 or 9 here, so it's 6, which makes this 7. And that makes that 6, and this 9. Yeah, it was because I messed this part up. I don't know how I messed that up. That's interesting. Yeah, I don't know how I made the assumption that this was 2. I think I eliminated 4, but I think I eliminated 4 incorrectly there. Anyways, yeah, this was actually significantly easier than the previous one that we did, using the same set. But I hope you enjoyed this solve, even though I kind of messed up this part here. And I'll see you next time on Frank Puzzles. Take care.